So imagine you're lugging around this massive invisible weight with you into every single room, every romantic relationship, and every professional challenge you face. For decades, we've talked about the pain of having a distant or absent father as being purely an emotional thing, right? Like it's just a psychological issue. But here's the core mystery we're unraveling today. Is the heavy burden of a distant father really just a feeling, or is it a physical, biological reality that we literally carry inside ourselves? Welcome to this explainer. Today, we're exploring the neurological architecture of the father wound. Specifically, we're looking at how the HPA axis, dopamine and approval seeking, and prefrontal cortex development are fundamentally shaped by childhood attachment. We aren't just talking about fading memories today, we're diving into the hard science of how early relational environments physically build the brain's architecture. If you've ever wondered why certain toxic relationship patterns feel literally impossible to break, or why all your achievements never quite feel like they're enough, well, you are in exactly the right place. Right, so first things first, let's define exactly what we mean here. When we say the father wound, we're talking about the lasting biological and psychological impact of a father's emotional unavailability, conditional love, or physical absence. And it doesn't just mean a dad who packed up and left. Actually, very often it means a father who was sitting right there in the living room, but he was emotionally completely unavailable, maybe hypercritical, or only offered his love when it was earned through some kind of achievement. That specific brand of conditional presence leaves a measurable mark on a developing child. To really understand this, we're going to map out the blueprint of the father wound. We'll start with the biological blueprint, then look at the HPA axis stress engine, dopamine and approval hunger, the prefrontal cortex and control, trauma bonds and relationships, and finally, rewiring the architecture. Okay, let's dive right into it. Section 1, the biological blueprint, more than just memories. So we have to start by shifting our paradigm away from just psychology to pure biology, because this wound, it is physically measurable. Listen, if you strolled into a lab today, you wouldn't even need a psychological evaluation to find this wound. A simple blood test would reveal a documentable biological burden. We'd likely see elevated C-reactive protein, which is a really clear marker of chronic inflammation. We'd see low vagal tone, basically meaning your body physically struggles to hit the brakes and calm itself down. We'd see a totally dysregulated daily cortisol profile, and even epigenetic marks on your DNA, specifically the FKBP5 gene that regulates stress. And here's the absolute most mind-bending part of recent epigenetic research. This biological blueprint can actually begin before you're even born. No way, right? But it's true. Paternal stress and unhealed trauma can alter the sperm epigenome. That means the starting calibration of your nervous system was influenced by his unexamined wounds before you even took your first breath. It's absolutely astonishing how deeply connected we are to our biology. Moving on to Section 2, the HPA axis stress engine, a body on chronic alert. Let's look at how this builds a body that is just stuck on chronic alert. The HPA axis, that's the hypothalamic pituitary adrenal axis, is our body's primary stress regulation system. Now, in a healthy nervous system, cortisol acts predictably. You get a nice, sharp morning peak to wake you up, it declines steeply in the afternoon, and drops deeply at night so you can actually get some rest. But for a child who has to constantly monitor the unpredictable emotional weather of a father, the body perceives that as a literal, constant threat. The HPA axis gets stuck running this low-grade emergency signal. So instead, you get a blunted morning peak, meaning you wake up already exhausted. You get sustained daytime activation and an elevated baseline at night. Your body is quite literally bracing for an emotional shift that might never even come. Let's map out that specific timeline for a second, because the nighttime impact is absolutely crucial. That incomplete cortisol drop at night actively compresses your slow-wave sleep. And why does this matter? Well, because slow-wave sleep is the exact time when your brain processes and consolidates emotional memories. The elevated cortisol environment physically prevents your brain from effectively processing the day's relational stress, keeping the emotional charge of the wound completely trapped in your system day after day after day. If you've ever sat there wondering why you can't just sleep off your anxiety, well, this biological roadblock is exactly why. Section 3. Dopamine and approval hunger, the neuroscience of overachieving. If you've ever wondered why incredibly successful, super-driven women often feel like they literally haven't done enough, this is the neurological answer. There's this incredibly powerful concept that emerges from the research. The slot machine has been built. It runs for the rest of her life. Think about how a slot machine actually works for a second. It's highly addictive precisely because the reward is unpredictable. In childhood, if a father's approval is intermittent, conditional, and tied entirely to high performance, it acts as a highly addictive variable ratio reward schedule. When a child experiences consistent, reliable warmth, the brain actually habituates to the love. It feels secure, calm, grounded. The dopamine system doesn't need to absolutely freak out because the love is reliable. But unpredictable affection, that creates a totally different neurochemical event. It wires the brain's reward center, the nucleus accumbens, to trigger massive dopamine spikes only when that rare crumb of approval finally arrives. And this wires the brain to constantly hunt for external validation in adulthood. Whether it's from bosses, mentors, or romantic partners, you're compulsively chasing that exact same dopamine hit.
All right, Section 4, the prefrontal cortex and control, the cost of chronic monitoring. So what actually happens to a child's brain when all their energy is spent monitoring someone else's emotional weather? Well, we see the development of what we call the monitoring brain. And I want to be super clear here. Frame these not as damage, but as highly sophisticated childhood survival mechanisms that just cost way too much in adulthood. We see intense hypervigilance to authority figures. We see elevated activation in the anterior cingulate cortex, which acts as the brain's alarm bell for social evaluation, leaving you incredibly prone to severe social anxiety. And honestly, most tragically, we see the suppression of the default mode network. This is the network responsible for spontaneous thought, daydreaming, and inward reflection. When you spend your entire childhood scanning the room to make sure your dad isn't angry, you lose the bandwidth to develop your own rich interior life. You also experience hippocampal volume reduction, which seriously compromises your ability to distinguish past threats from present reality.
Which leads us directly into Section 5, trauma bonds and relationships, recreating the blueprint. That compromised hippocampus silently dictates our adult, romantic, and professional lives. Watch how we unconsciously seek the original wound in others. First, you encounter a partner who is unpredictable or emotionally unavailable. Because your hippocampus has been compromised by years of chronic cortisol, it literally fails to distinguish this new person from your father. Your HPA axis triggers, and suddenly, that deep feeling of unsafety registers in your brain as familiarity. Then, when this unavailable partner eventually gives you a tiny crumb of intermittent affection, your brain delivers a massive dopamine spike. And here is the real tragedy. Your nervous system mistakes that intense, anxiety-driven dopamine spike for true love. But it's not true love, it is literally just a pattern match of your childhood slot machine. Finally, Section 6, rewiring the architecture, the science of earned secure attachment. Here is where this explainer takes a radically, beautifully hopeful turn. Because the human brain is highly plastic, this biological burden is entirely reversible. We call this the science of earned secure attachment. So, the absolutely crucial point is this: you are not permanently broken. The data clearly shows that hippocampal atrophy is physically reversible. Through targeted approaches like schema therapy and internal reparenting, you can literally build brand new neural pathways. By engaging in consistent, secure, almost boringly safe relationships, you can retrain your HPA axis and lower that chronic cortisol baseline. And as you do this work, as you heal, your dopamine system shifts away from the anxious, reactive seeking of external approval, and it moves toward perspective hope, that quiet, grounded motivation of pursuing a life you actually desire. So, we've mapped out the biology, the stress engines, the reward circuits, and those tricky relationship loops. The architecture of the father wound is real, it's measurable, and most importantly, it is entirely capable of being rewired. Now that you understand the original blueprint that was handed to you, what are you going to build next? Thank you so much for joining me on this explainer. Until next time, keep learning, keep healing, and keep building.